Robert.
And I'm Jörg.
Yes. And now we introduce you today in extreme programming.
Extreme
programming, yes. And after all, what is XP? Okay, XP is a lightweight, efficient, low-risk, flexible, practicable, scientific and fun way to develop software. It is distinguished from other methodologies by its early, concrete and continuing feedback from short cycles, its incremental planning approach, which quickly comes up with an overall plan that is expected to evolve through the life of the project. Its ability to flexibly schedule the implementation of functionality responding to changing business needs. Its reliance on automated tests written by programmers and customers to monitor the progress of development to allow the systems to evolve and to catch defects early. Its reliance on oral communication, tests and source code to communicate system structure and intent. Its reliance on an evolutionary design process that lasts as long as the system lasts. Its reliance on the close collaboration of programmers with ordinary skills. Its reliance on practices that work with both the short-term instincts of programmers and the long-term interests of the project. So now, Jörg?
Now we come to the problems of extreme programming. So these are as follows. Basically you have to deal with risks, all kinds of it. We're gonna speak about that in detail later. You have to schedule of day-to-day programming. You have the problem of software programming, which contains following aspects: the cash flow, in and out, the interest rates, and the project mortality. You have the control of the 4 important variables in our project, which is cost, time, quality, and scope. You have cost of change, which is cost of changing a program rises exponentially over time. Learning to drive. We need to control the development of software by making many small adjustments, not by making a few large adjustments. It's kind of like driving a car. The 4 values: communication, simplicity, feedback, and courage. And last but not least, the principles. The 4 basic activities: coding, testing, listening, and designing. And now for our next guest, Mr. Solution.
Okay, the solution turns the abstract ideas in the first section into the practices of an actual methodology. So let's take a look at some important components and aspects of extreme programming. The planning game quickly determines the scope of the next release by combining business priorities and technical estimates. As reality overtakes the plan, update the plan. Small releases put the simple system into production quickly, then release new versions on a very short cycle. Metaphor: guide all development with a simple shared story of how the whole system works. Simple design: the system should be designed as simple as possible at any given moment. Needless complexity is removed as soon as it is discovered. Testing: programmers continually write unit tests which must run flawlessly for development to continue. Customers write tests demonstrating that features are finished. Refactoring: programmers restructure the system without changing its behavior to remove duplication, improve communication, simplify or add flexibility. Pair programming: all production code is written with 2 programmers at one machine. Collective ownership: anyone can change any code anywhere in the system at any time. Continuous integration: integrate and build the system many times a day, every time a task is completed. 40-hour week: work no more than 40 hours a week as a rule. Never work overtime a second week in a row. On-site customer: include a real-life user on the team, available for full-time to answer questions. Coding standards: programmers write all code in accordance with rules, emphasizing communication through the code. So be aware of the different strategies which are used for XP. There is the management strategy. The strategy that emerges from this evaluation is more like decentralized decision-making than centralized control. The manager's job is to run the planning game, to collect metrics, to make sure the metrics are seen by those whose work is being measured, and occasionally to intervene in situations that can be resolved in a distributed way. Facility strategy: create an open workspace for our team, with small private spaces around the periphery and a common programming area in the middle. Reserve a little of the nicest space of the one side for a communal space. Put in an espresso maker, couches, some toys, something to draw people there. Splitting business and technical responsibility. The solution is to somehow split the responsibility and power between business and development. Business people should make the decisions for which they are suited. Programmers should make the decisions for which they are suited. Each party's decisions should inform the others. Never party should be able to unilaterally decide anything. The planning strategy. Planning is the process of guessing what it will be like to develop a piece of software with a customer. Some of the purposes of planning are to bring the team together, decide on scope and priorities, estimate cost and schedule, give everyone involved confidence that the system can actually be done, provide a benchmark for feedback. Also important in this phase are so-called story cards. These simple cards can be used to write down a requirement the customer wants. Development strategy. The development strategy begins with iterating planning. Continuous integration reduces development conflicts and creates a natural end to a development episode. Collective ownership encourages the whole team to make the whole system better. Finally, pair programming ties the whole process together. Design strategy. The design strategy in extreme programming is to always have the simplest design which runs the current test suite. Testing strategy. Who is writing tests? Programmers and customers. The circumstances to write a test case for programmers. If the interface for the method is at all unclear, you write a test before you write the method. If the interface is clear, put your image that the implementation will be the latest bit complicated. You write a test before you write the method. If you think of an unusual circumstance in which the code should work as written, you write a test to communicate the circumstance. If you find the problem later, you write a test that isolates the problem. If you are about to refactor some code and you aren't sure how it's supposed to behave and there isn't already a test for the aspect of the behavior in question, you write a test first. The customer writes tests story by story. The question they need to ask themselves is, what would have to be checked before I would be confident that this story was done? Each scenario they come up with turns into a test, in this case a functional test. So now to the implementation.
Following the implementation of extreme programming, how to adopt it, what is expected from the various people in extreme project, and how XP looks to the business folks. So first up, adopting extreme programming. It's one practice at a time, always addressing the most pressing problem for your team, and once that's no longer your most pressing problem, go on to the next problem. Retrofitting extreme programming can be a challenge with a new team. Adopting it with an existing team, an existing code base is even harder. You have all the existing challenges, learning the skills, coaching, making the process your own. You also have the immediate pressure of keeping production software running. So the life cycle of an ideal extreme programming project would be first exploration, planning, iterations to first release, productionizing, maintenance, and dev. Don't forget the different roles for different people. To make an extreme project running, you need different roles, which is for once the programmer, the customer, the tester, the coach, the tracker, the consultant, and the big boss. So what exactly makes extreme programming hard? Well, it's hard to do simple things. It's hard to admit that you don't know something. It's hard to collaborate. It's hard to break down emotional walls. So after all, you still have to accept responsibility for your own process. But what makes extreme programming hard is exactly this. By accepting responsibility for your own development process, you're accepting responsibility for being aware and fixing it when there's a problem. So when should you not try extreme programming? The biggest barrier for the success of XP project is culture, especially business culture, because you need the two sides, and if resistance is too big, it will fail. If your employers expect more than 40 hours a week, it won't work, because tired people cannot handle extreme programming. Your team consists of more than 10 people, and they are separated by rooms, floors, or even continents. Also bad. You should not use XP if you're using a technology with an inherently exponential cost curve. And another technology barrier for XP is an environment where it takes a long time to gather feedback. So for additional concepts, we go on to talk to our reporter, Robert.
Thanks. So now the additional concepts we're going to talk about With me, Mr. Gum. Ping pong programming is. Ping pong programming is an offspring of two well-known extreme programming practices, pair programming and test-driven development. How does it work? Ping pong is one of the most basic activities used when teaching test-driven development. The rules are simple, work in pairs. Person A only writes test, person B only tries to get the test to pass. Both persons refactor when appropriate. During the activity, it is a good idea to ask participants to switch rules. Person B becomes the test writer and person A becomes the test taker. Depending on how quickly the pairs pick up the activity, you can either ask participants to swap rules in the middle of the session, or you can repeat the exercises and ask participants to switch rules in the next session. Thank you.
The project velocity. The project velocity is a measure of how much work is getting done on your project. To measure the project velocity, you simply add up the estimates of the user stories that were finished during the iteration. You also total up the estimates for the tasks finished during the iteration. Both of these measurements are used for iteration planning. During the iteration planning, meeting customers are allowed to choose the same number of user stories is equal to the project velocity measured in the previous iteration. Those stories are broken down into the technical tasks and the team is allowed to sign up for the same number of tasks equal to the previous iteration's project velocity. This simple mechanism allows developers to recover and clean up after difficult iterations and averages out estimates. Your project velocity goes up by allowing developers to ask the customers for another story when their work is completed early and no cleanup tasks remain.
Thing is YAGNI. YAGNI is originally is an acronym that stands for You Aren't Gonna Need It. It is a mantra of extreme programming that's often used generally in agile software teams. It's a statement that some capability we presume our software needs in the future should not be built right away because you aren't gonna need it for now. YAGNI only applies the capabilities built into the software to support a presumptive feature. It does not apply to effort to make the software easier to modify. YAGNI is only a viable strategy if the code is easy to change, so expanding effort on refactoring isn't a violation of YAGNI because refactoring makes the code more malleable.
Track factor. The track factor is a measurement of the concentration of information in individual team members. It specifies the number of team members that can be unexpectedly lost from a project, so hit by a truck as it were, before the project collapses due to the lack of knowledgeable or competent personnel.
So, and now what are risks in traditional software development? Schedule slips. The day for delivery comes and you have to tell the customer that the software won't be ready for another 6 months. Project cancelled. After numerous slips, the project is cancelled without ever going into production. Systems go sour. The software is successfully put into production, but after a couple of years the cost of making changes or the defect rate rises so much that the system must be replaced. Defect rate. The software is put into production, but the defect rate is so high that it isn't used. Business misunderstood. The software is put into production, but it doesn't solve the business problems that was originally posed. Business changes. The software is put into production, but the business problems it was designed to solve was replaced 6 months ago by another, more pressing business problem. Fails feature rich. The software has a host of potentially interesting features, all of which were fun to program, but none of which makes the customer much money. Staff turnover. After 2 years, all the good programmers on the project begin to hate the program and leave.
Why software development is more similar to city architecture and engineering than building architecture? Well, software development is an ever-evolving process. Adjustments have to be made on the fly and changes in plans are plenty. The decision-making process is decentralized, each team member specializing on their own role, rather than one architect calling shots and taking over the design on his own.
They had survived the protection wars. There was between the mighty forces of the god. They have survived the time in mountains deep inside, unknown to earth and skies. In the desolate places, only sure they